Astronomers and scientists, observing the steady expansion of the universe, have tried to imagine the origins of all matter. A point in time billions of years ago, when the universe began its sudden expansion in what is known as the Big Bang. In the first instance, when the temperature was over 2,000 billion degrees, the basic particles of matter existed freely before cooling enough to form protons, neutrons, and other composite particles. Scientists today studying the nature of these fundamental elements are using the most powerful and complex machines ever built by man to smash subatomic particles together at extremely high speeds, and by doing so, recreate, if only for a split second, the conditions immediately after the Big Bang. The Large Hadron Collider, on the border between France and Switzerland, is the world's largest and most powerful particle accelerator. Its main structure is a 27-kilometer-long vacuum tube buried in a tunnel 100 meters below the ground to shield it from cosmic rays and other external interference. At the beginning of an experiment, hydrogen atoms are fed into the chamber of a linear accelerator, where their negatively charged electrons are removed to leave positively charged nuclei or protons. This allows them to be accelerated by an electric field to an initial speed of roughly 100,000 kilometers per second, or 1/3 the speed of light. The packets of protons are accelerated faster and faster by being repeatedly pushed by an electric pulse, while powerful magnets are used to bend the path of the protons and keep them within the circular tubes. The protons reach 91.6% of the speed of light before being recombined into a single beam and flung into the third stage of acceleration. Here, the packets reach 99.9% of the speed of light, and as the speed of light cannot be exceeded, additional energy added by the electric fields do not make the protons go faster, but increases their mass instead. In the fourth stage, the packets are energized further before being launched into the orbit of the gigantic Large Hadron Collider with a circumference of 27 kilometers. Here, the protons travel in two separate vacuum tubes in opposite directions until their mass reaches 7,000 times heavier than when at rest, and they are finally allowed to collide. Huge complex detectors built around the impact point identify the secondary particles produced in these collisions and measure their positions, their charges, speed, mass, and energy, while a massive network of computers is used to record, analyze, and store the resulting information. It is hoped that these experiments will give new insight into the fundamental building blocks of our universe and answer questions about its origins and destiny. And that's amazing technology shining bright in the stars of science galaxy.